Back to my channel Maths with Armin. This is another video on factoring cubic polynomials of the type ax cubed plus bx squared plus cx plus d. In this video, I'm going to show you how to use your scientific calculator and specifically how to use the table mode on a scientific calculator to factorize cubic polynomials. If you have not yet subscribed to my channel Maths with Armin, please subscribe. In this video, I'm going to use the scientific calculator, the Casio Fx82ZA Plus, but it can also be done on other models of Casio and also on other brands of calculators. This is just the example of the Casio calculator that I'll be using. Start using the calculator. Let's just briefly go through the factor theorem. If fa is equal to 0, then x minus a would then be a factor of fx. For example, if I have f of negative 2 being equal to 0, then x plus 2 would then be a factor of fx. Similarly, if f plus 3 is equal to 0, then x minus 3 would then be a factor of fx. Conversely stated, if x minus a is a factor, then fa would be equal to 0. For example, if x minus 3 is a factor of fx, then f positive 3 would be equal to 0. I'm going to start now showing you on your Casio Fx82ZA Plus how to access the mode function. You have to select mode. As you can see, there is mode there. So in other words, mode. You touch on mode, you'll see this screen appearing on your calculator. Now, because we want the table mode, there are different modes here, but we want to take the table mode, so I have to enter 3. If I press the 3, after pressing the 3, you'll see this appear on your screen. Now you're ready to enter the expression for your polynomial fx. In the next slide, I'll show you how you can enter the expression. How we're going to enter this algebraic expression, fx equal to x to the 3 minus 3x squared minus 6x plus 8, this cubic expression. Okay, so first let's see how we enter x3. What you have to do first of all, you have to press alpha, and you see there's alpha, and then that's the alpha key, and as soon as you press the alpha key, then immediately after the alpha key you press this bracket key down here, and then you'll see that an X will pop up on your screen. Okay. Now you then press this power key here, X to the power. If you press that, you'll see that appear on your screen. And then because you want a cube, you'll press it, enter a 3. You enter the 3. Once you enter the 3, there you've got x cubed. Right? Now let's continue with the rest of the terms, negative 3x squared. So first of all, you just have to enter a negative 3. You enter a negative 3, that's what you get. Now you want to x. How do we get x again? Alpha in the bracket. So we go alpha in the bracket, and there's my 3x. Right? Now because I want square, I can just use a square key. You see there's a key there? X squared, look for that key. If you press that, you'll see x squared coming. Now the same way here, we want to enter negative 6x plus 8. So we'll enter negative 6, and then we go alpha bracket, and immediately you then get a negative 6x. And a plus 8 is just a normal plus with the 8. If I do that, there I've got my cubic expression, x to the 3 minus 3x squared minus 6x plus 8, or x cubed minus 3x squared minus 6x plus 8. Show you how you can use your table mode to factorize fx equal to x cubed minus 3x squared minus 6x plus 8. First of all, like we just shown, you have to enter your expression. So let's say there we've entered our expression. So what do we do next? You press equal. Once you press equal, you see the word start appears on your screen. Now, how do we start? we have to look at this constant value. That constant value indicates here what your factors would be, right? So your factors can either be positive or negative. So you'll start at, let's say it's a 8, so let's use negative 8. You enter negative 8. Then you press the equal again, and you'll see the word end. Where do you end on the positive side? Right? You've got a range from negative 8 to positive 8. You press equal. Once you press the equal, you see the word step. Now, default step will be 1. In other words, I'm just going to work in steps of 1. Right? In other words, it will go negative 8, negative 7, negative 6. Just in steps of 1. The difference between the terms would be 1. My default step, always try to make that a 1. You press equal, and once you press equal, you see a table of values appears there. You've got a column for x. These are you see there it starts from negative 8, negative 7, right, and then you get the output values. Now you have to scroll down, because to determine whether something is a factor, the fx value should be 0. So wherever the fx, so you scroll down, you can use these keys to scroll down. You scroll down, and now if we scroll down, we're now going to get our, so if I scroll down, the first value I get there, I see by f equal to negative 2. By f equal to negative 2, the output is 0. So if f negative 2 is 0, from the factor theorem, x plus 2 is a factor. I scroll down further, and I see f1 is 0. Now, if 1 is 0, it means x minus 1 is a factor. I scroll down further, and there I get it, f4 is 0. So if 4 is 0, x minus 4. And there you've got your factors for x cubed minus 3x squared minus 6x plus 8. Quick check. 2 times negative 1 is negative 2. Negative 2 times negative 4 is positive 8. Okay? So just briefly there, once you've entered your expression, you press start. Now it will ask you what your range would be. And this constant value, the range you would get there would be between negative 8, then it will end at 8. So it's start at negative 8, end at 8. And always make your default stepper 1. You'll get a table of values appearing, and you just have to look for where the output value is. And you'll see that 0, you'll always see a 0 coming up here. Right? That tells you your output is 0. Second example, fx equal to x cubed plus 6x squared minus 8x minus 30 with a negative constant there. So first of all, we have to enter our expression. Right? So enter our expression. Once we have entered our expression, we press equal. And after you press equal, you get start. There we've got a constant of negative 30. Let's start with negative 30. Let's see. So I start with negative 30. And I end with negative 30, and our steps, we just always make it 1. And now I press enter, and what do I get on the screen? Insufficient memory, right? This means that my range of values from negative 30 to 30 is too big for the calculator. I can again try maybe negative 10, which is also a factor of 30, or I can even take something smaller than negative 10. I could take negative 15. But let's start with something a bit smaller. Let's take 6. So we're going to start at negative 6. I press to clear the screen. You press AC, all clear, and you end back with your function. Okay. So let's enter negative 6, and we end with 6, and we end with step of 1. Now if I press equal, I get a table of values. So I'm now ready to get my factors there. So first of all, we scroll down, and once we scroll down, wherever we see a 0, right? So I know if negative 5 gives me 0, and if f negative 5 is 0, x plus 5 is a factor. Scroll down further, and I see f negative 3 is 0. If negative 3 is 0, means x plus 3 is a factor. Scroll down further, there I see f2. So f2 is 0, which means x minus 2 is a factor. And there I've got my 3 factors, x plus 5 times x plus 3 times x minus 2. You can check 5 times 3 is 15. 15 times negative 2 is negative 30. we've got x cubed plus x squared minus 16x plus 20. So we first have to enter that expression, and there we've got our expression, right? Now we press equal, and then we get start. I can see there we've got 20. 20 might be a bit too large there, so to go from negative 20 to 20 might lead to insufficient data. Let's take a smaller factor. We take negative 5. We start negative 5. We end at positive 5. And our step would be 1. That's the default step always. We then scroll down. Now we're ready to get our factors. Let's scroll down and see. The first value we get is f negative 5 is going to give me a 0. Okay. So if f negative 5 is 0, then x plus 5 would be the factor. We scroll down further and we see f2 is equal to 0. So we enter f2 is equal to 0, therefore x minus 2 is a factor. But if we scroll down, we don't see any other factors after 2, nothing else. So what does that mean? What would our other factor be? Let's see what it could be. We already have a 5 and a negative 2. 5 times negative 2 with what? That's a missing one. Must give me my 20. 5 times negative 2 is negative 10. Negative 10 times, that's correct, times negative 2. So my other factor here is x minus 2. So here we notice the table only gave me 2 values. That indicates to me that one of the factors would be repeated. Okay, and which one you can easily follow. I couldn't have another 5, because if I had another 5, 5 times 5 would be 25, times 2 would be 50, and I don't have a 50. So if you have 2 values here only appearing, it means one of them would be a repeated factor. And you can easily by inspection see which one is repeated. In this example, we've got a cubic expression where the leading coefficient is not 1. You can see there, this is a 2x cubed, not a 1x cubed. So we're going to see what we do here. We do exactly the same. We first of all have to enter our expression. So once you've entered your expression, you press equal. And now we want the starts. So where's the start? The start can be from negative 20 to 20, but let's take a smaller starting point. From negative 5 to 5. Otherwise, we'll have insufficient data. Step 1. Now once we do that, we get a table, and we just have to scroll down to find 0. So now we can get the actual factors there. We scroll down, the first value we would find is f of negative 4 is 0, which means x plus 4 is a factor. We scroll down further, and we have f1 is equal to 0, which means x minus 1. But scrolling down any further, we see there are no further factors. So what would that missing factor be? Now, because we had a step of 1, we're only working with integers, right? And because I have a 2, one of my factors would involve a fraction. So I would only get integers in my table. So let's do it by inspection now. I am given a 2x cubed. So x, I already have an x and an x. So x times x with what will give me 2x cubed? That's right, times 2x. So that term there is 2x. Let's look at the constant. We've got a negative 20. We already have a 4 and a negative 1. 4 times negative 1 is negative 4. Negative 4 times what is negative 20? Correct? Positive 5. So there I've got my other factor, right? So note, because I have a step 1, I will only get integers there, right? So to get that, I'll just have to get my last one there, and see that's where the 2x comes in. And here, if I have to find this out, this should actually be f of negative a half. But because of my steps being 1, not fractional, I won't get any fractions on my table there. So just use a step 1. You can just find your last factor by means of inspection. Another example where the leading coefficient is not 1. Here we can see the leading coefficient is 3. So first of all, we enter our expression. There we've got our expression entered. Then we press that. Now we have to get our start. What will our start be? We're going to use negative 6 and end positive 6 plus 12 will give you insufficient data. In a step, we just keep to the step of 1. Just work with integers and then scroll. Now I have to see, there's my expression. I have to scroll down. First value I would find would be f negative 3 is 0, which means x plus 3 is a factor. I scroll down further, I have f2, and that only is the integral values that I'm getting, right? Only integers. Now how do I get the fractional part? Do that by inspection. I've got a 3x cubed, and I already have an x and an x times what? That's correct, it will just be 3x. So in other words, I have to enter 3x there. Let's look at the constant, negative 12. I already have 3 and a negative 2. So 3 times negative 2 is negative 6. Negative 6 times what? Negative 6 times positive 2. So that factor there would be 3x plus 2. Example here. I've got x cubed plus x squared plus x plus 6. There we've got our function already entered. And now we need to add the start. We've got the 6. Let's just take a negative 6 as a start and end at a positive 6, and a step would be 1. Right? We enter, and then now we need to scroll down. And if I scroll down, I would find I get f negative 2 is equal to 0. That means x plus 2 is a factor. And I scroll down and scroll down, and I don't find any others. Right? So the only one I have found at this stage is this 1, x plus 2. Now because that one is a x linear, the other factor would have to be a quadratic. So let's find the quadratic there, and we can do this by inspection. We are given a x3. We already have a x, or x with x squared. That's where the quadratic comes from. That is a quadratic. We are given a constant of 6. We already have a 2. So 6 will be 2 times what? 2 times 3. So my constant term there is 3. I only need to find the middle term. At the moment, I've got a 2x squared, but I was given a 1x squared. So what must I do with the 2x squared so I can get my 1x squared? That's right, it must add a negative x squared. So I'm going to add the negative there. But I don't write down x squared because the middle term is not a square. Because I can see I do get the square if I expand it. X times x will be x squared. So when you've got a square there, you don't put the square there. So if you only have one factor coming out, it means you have to get a quadratic factor for the other. Because we only have, in this case, we only have one real factor there. In this, to be more specific, one real rational factor. We're going to look at another example to illustrate it. Another example where we only have one real linear factor. I've got my expression already entered. And now I have to get my start. I've got a negative 9. Let's try negative 9 as a start. And the end is positive 9. And the step there is 1. And now we can get our table of values. We have to scroll down. And if we scroll down, we get f3 is equal to 0. And we scroll and scroll, and we find no other values except f3 equal to 0. So we only have one linear factor, x minus 3. We can then find the corresponding quadratic factor by inspection. How do we do that? I'm given a x cubed. So I already have an x. So x times x squared will be x cubed. So I'm going to have an x squared. I look at my constant. I've got a negative 9. Already have a negative 3. Negative 3 times positive 3 will give me 9. My constant for the quadratic would be plus 3. I've got a negative 3x squared, but I want a negative x. So I have to add 2x squared. So I will have a 2x there, but not, just remember 2x, not 2x squared. And there we factorize that. So if we have a linear one, then we can get the corresponding quadratic. We have 6 questions for you to try. 3 with a leading coefficient of 1, and 3 with a leading coefficient of, in this case, a 2, and a 3 and a 3. You'll find the solutions on the next slide. solutions to the 6 questions. You can pause and try. So there, the first one is the leading coefficient of 1, and the next 3 with a leading coefficient, in this case, of a 2, a 3, and a 3. Also recommend that you watch some of my other videos on factorization. I have a video on using the factor theorem to factorize. In other words, in this video, I show how you can just use the factor theorem to factorize. Or there's also another one where you can also factorize ax cubed plus bx squared plus cx plus d. And in this case, I'll do it by means of inspection. Just a different method. Instead of the calculator, I can show you how to do it by inspection. Actually, this inspection one is actually the easier of all the types of methods for factorizing cubic expression ax cubed plus bx squared plus cx plus. I do hope you've enjoyed this video on factorizing cubic expressions. There are also many other videos on mathematics topics aside from the factorization that I've prepared, and I would recommend that you go and watch those videos as well. And please, if you have not subscribed to my channel Maths with Armin yet, please subscribe. Thank you very much for watching my video.